Hello, this video is for IXL Activity A1.B.5. It is titled Multiply and Divide Rational Numbers. The 3-character code for this activity is Hotel 6 Lima. So rational numbers, and particularly fractions or decimal numbers. Numbers that aren't so friendly sometimes. Not numbers like 1, 2, 3, 4, 5, which actually 1, 2, 3, 4, 5 are rational numbers because you could write 5 as 5 over 1, it would be a fraction. But we're talking about fractions, decimals, mixed numbers. How do we deal with those? Well, whenever we multiply fractions, in the past we've learned that to multiply fractions, we just multiply straight across, right? Multiply numerator times numerator and denominator times denominator. And so if we do that with the first one here, we would get 3 times 1 is 3, and 4 times 6 is 24. Now, both 3 and 24 will divide by 3. 3 divided by 3 is 1, and 24 divided by 3 is 8. So we would arrive at an answer of 1/8. Now, however, sometimes, at least I think it's easier to go ahead and cancel or factor out some factors instead of simplifying the fraction at the end. Let's go ahead and cancel out some factors through cross-canceling. And we call it cross-canceling because you're going to cancel something out of the numerator that you can also cancel out of the denominator. For instance, 3 and 6. 3 and 6 both share a common factor of 3. So let's factor 3 out of both 3 and 6. 3 divided by 3 is 1, so we'll replace that with a 1. And 6 divided by 3 is 2. Now we can go ahead and multiply straight across. 1 times 1 is 1, and 4 times 2 is 8. And we end up with the same answer of 1/8. However, we don't have to simplify it. It's already simplified for us because we've already factored out the factors at the beginning of the problem instead of doing it at the end of the problem. Now, you might think, oh, 4 and 2 have common factors, so 2 divided by 2 is 1 and 4 divided by 2 is 2. No, you can't do that. You see, the reason for that is that the 4 and the 2 are both in the position of denominators. They're not, one's not in the denominator and the other in the numerator. You have to have one in the numerator and the other in the denominator to cancel factors. Now, what about dividing fractions? Well, some of you might be thinking, oh, I know that. That's keep, flip, change, right? We're going to keep the first fraction the same. We're going to flip the second fraction. And we're going to change the sign. So let's go ahead and rewrite this problem. Let's keep the first fraction, 1 over 8. Let's flip the second, 2 over 1. And let's change the sign from division to multiplication. And we're going to use a dot for multiplication. Now, notice that 2 and 8, one's in the numerator, the other is in the denominator. We can go ahead and cancel the factor of 2 out. 2 divided by 2 is 1, and 8 divided by 2 is 4. So 1 times 1 is 1, and 4 times 1 is 4, and we end up with the answer of 1/4. Now let me ask you this. Do you know why keep, flip, change works? Well, check this out. I'm going to go ahead and erase this here. It has to do with inverses and the rule of any number over 1 is equal to itself. But this is pretty neat. And if you realize why it works, you'll know something that many math teachers don't even understand. They just know the shortcut, but they don't know why it works. Remember that a fraction is a division problem? So this sign, this division sign, we could represent that using a fraction bar. We could actually put a fraction over a fraction. 1/8 divided by 1/2. Now we know that anything over 1 is equal to itself. So if we turn the denominator into 1, then whatever would be in the numerator would be left over. Well, the identity property of multiplication is 1. And the inverse property gets us back to the identity property. It's a bunch of stuff about properties we might learn later on. So what if I multiplied 1/2 times its inverse? Its inverse would be 2 over 1. But what I do to the numerator, I have to do to the, or what I do to the denominator, I have to do to the numerator. So let's multiply it times 2 over 1. Now, with this, we end up with 2 times 2, or 2 times 1 is 2. 2 times 1, again, is 2. Any number over itself equals 1. So now all of this here equals 1. So whatever's anything over 1 equals itself. If I had 5 over 1, that would equal 5. So we could just say, get rid of the denominator of 1 and take whatever's in the numerator. Well, what do we have in the numerator? The numerator is 1 over 8 times 2 over 1. Isn't that exactly what we did? We keep the first fraction, flip the second fraction, and we change the sign. The reason that keep, flip, change works has to do with inverse properties and identity properties, and that anything over 1 is equal to itself, or that is to say anything divided by 1 is equal to itself, and that's why keep, flip, change works. All right, let's move along. On the next one, we have multiplication here. We also need to know something else on this activity. We need to know that actually need a pen, right? We need to know that positive times positive equals a positive, that a negative times a negative equals a positive, and that a negative times a positive equals a negative, and that a positive times a negative equals a negative. Long and the short of it is, if they are both positive or if they're both negative, they equal positive. If one's negative and the other one's positive, then the answer is going to be negative. All right, a little bit of a refresher course there, so keep that in mind. So we have a negative number here times a negative number here, so we know that our answer here is going to be a positive number. All right, so keep that in mind. Let's go ahead and multiply straight across. Oh, wait a second. 4 divided by 4 is 1, and 4 divided by 4 is 1. They both have a factor of 4. We can factor that out. Negative 1 times negative 1 is positive 1, and 5 times 1 is 5. Our answer is 1/5. Division of fractions. Let's go ahead and do keep, flip, change. And again, we have negative times a negative, or negative divided by negative, and that's not positive. My brain's freaking out because I'm trying to remember the rules for multiplication of positive and negative numbers is identical to the rules for the division of positive and negative numbers. So negative divided by negative, it's going to be positive. So we know our answer is going to be positive. We can't really factor anything out. Oh, wait, silly me. I'm trying to factor stuff out, and I haven't done keep, flip, change yet. So let's keep the first, negative 1 over 8. Let's flip the second, 10 over, and we could put negative 1 here, but I won't put the negative sign up top because I like my negative numbers to be in the numerators. That's okay. Multiply, change the sign. Factor 2 out of 8, that gives us 4. Factor 2 out of 10, that gives us 5. Now let's go ahead and multiply straight across. Negative 1 times negative 5 is positive 5. 4 times 1 is 4. And for this activity, you could put, you can't put 4 over 5. You could put 5 over 4. Now if you wanted to change this to a mixed number, it would take that as well. Remember, this is a division problem. 5 divided by 4, or 4 divided by 5, no. 5 divided by 4 is 1. 4 will go into 5 once, with a remainder of 1, and the denominator stays as 4. So 4 goes into 5 one time. There's a remainder of 1. That's the numerator. And we work with the same denominator, 4. So you could put 1 and 1/4 in, or it would also take 5 over 4. Here we are, multiplication of decimals. Now, many people are probably going to use a calculator for this, but let's revisit the way that we learned, or hopefully we learned years ago. We could go ahead and stack these up. 3.4 times 0.5. We're going to multiply using the old tried and true algorithm. 5 times 4 is 20. Carry the 2. 5 times 3 is 15. Plus 2 more is 17. I have one number after the decimal here. One place value at the decimal here. 1 plus 1 is 2, so we need to move the decimal over 2 places. So starting here, 1, 2. We'd end up with 1.70, and we really don't need the 0 on the end, so we just have 1.7. On the other one, we have negative 0.5 divided by negative 0.2. Now we could do long division for this. We could actually put our sign here, and let's forget about the negative signs for now, because negative times negative is going to be positive. So let's just remember our answer is going to be positive. I could do the 0.5 is being divided by 0.2. The decimal moves over one place, decimal moves over one place, but the decimal here, 2 will go into 5 twice. That's 4, 1, and bring down a 0. And 2 goes into 10 5 times. And that would give us 5 times 2 is 10. And 0, we could do it that way and get 2.5. Another way we could do it is if you're pretty good at changing decimals over to fractions. Again, let's forget the negative signs and just, we know the answer is going to be positive. 0.5 as a fraction would be 1/2. And 0.2 as a fraction would be 20% into fifths, 1/5, right? 1/5 should be right. Yep, 20%, 1/5. And this is division. Then we could just go ahead and keep the first, flip the second, change the sign, and we'd end up with 5/2. And we know that 2 goes into 5 twice, with a remainder of 1, and the denominator stays the same, and we come up with 2.5, which is the same as 2.5. And IXL will take either answer for this activity. As a matter of fact, they'd even take 5/2, I believe. It'll take improper fractions. On the next one, we have mixed numbers. So mixed numbers. In order to deal with mixed numbers, we have to change them over to improper fractions. Remember, an improper fraction is a fraction in which the numerator is greater than the denominator. The top number has a greater value than the bottom number. So in order to convert this, think of A as the number out front of the fraction. We'll do B as the numerator, C as the denominator, and to get to a improper fraction from a mixed number, we need to do C times A, multiply C times A, then add to it the value of B, and then all of that's going to be over the same denominator of C. So in this activity, you'll see me quite often say this times this plus that, right? This times this plus that, and then the denominator is going to stay the same. So negative times negative is going to be a positive. So we know that our answer is going to be positive. So I'm just going to forget the negative signs for now. So 6 times 7 is 42. And add 1 is 43. And that's over 6. Divided by 3 times 1 is 3. Plus 1 is 4. And that's over 3. Now I need to keep the first. 43/6. Flip the second. 3/4. Change the sign. I can factor out a 3 out of 3. Factor 3 out of 6 leaves me with 2. And now I have 43 times 1 is 43. 2 times 4 is 8. So we could put in 43. This would work. They'll let you use an improper fraction. You could put in 43/8. Or you could say 8 goes into 43 5 times. 8 times 5 is 40, with a remainder 3. And the denominator stays 8. So either one of these answers would work for this particular activity. Look at the next one. We have 1 and 1/2. It's negative times negative. So our answer is going to be positive again. So let's just forget the negative signs now. And let's go ahead and turn these into improper fractions. 2 times 1 is 2, plus 1 is 3. That's going to be over 2, same denominator. Times 4 times 2 is 8, plus 1 is 9. And that's over 4. Correct? 8, 9, yep. Now, I like the way that they make the 3 and the 9 share a common factor of 3, and 2 and 4 share a common factor of 2. They're wanting to see if you'll cancel those out, but they are not opposite of each other. So let's go ahead and do this. 3 times 9 is 27, and 2 times 4 is 8. So you could put 27/8 as an answer. Another possibility would be 8 goes into 27 3 times with a remainder of 3, and the denominator would stay 8, so you could put in a mixed number of 3 3/8. Another way we could have approached this. Let's look at it this way. 1 1/2. Well, let's make the decimal 1.5 times, and 2 1/4. Well, that would be 2.25. So you could turn them into decimals, and you could stack them, multiplying them using the traditional algorithm, Or you could go ahead and use a calculator, which I think a lot of people would use a calculator. But still, you'd have to know how to change the fractions over to decimals in that case. So let's look at our next one. Here we have a positive divided by a negative. So in this case, our answer is going to be negative. So let's just remember the answer is going to be negative, and let's go ahead and work this one out. So 3 times 2 is 6 plus 1 is 7. So I'm just converting these mixed numbers into improper fractions. Denominator times the whole number plus the numerator becomes your new numerator, and your denominator stays the same. Remember, that's that A, B over C is equal to the value of C times A plus B over C. So that's what I'm doing here, right? 3 times 1 is 3, plus 1 is 4, and that's over 3. The denominator stays the same. It is division. Now let's do keep, flip, change, right? Keep the first, 7 over 3. This is going to be nice. Flip the second one, 3 over 4. Change the sign to multiplication. Let's factor the 3 out of each of those, right? Those are going to become 1s. 7 times 1 is 7. 1 times 4 is 4. So we could put in the answer of 7 over 4. Or how many times is 4 going to 7? Once. What's the remainder? 3. And the denominator stays the same. Or you could put it in 1 3/4. On the next two problems here, on these, I would suggest you could make 0.5 into a fraction of 1/2. You could do 1/2, that's negative, divided by 2/5. Why not? Let's go ahead and do that. So negative times a positive is going to be negative, so we know our answer is going to be negative. Let's put that there. Now let's keep the first. Let's flip the second. And let's go ahead and change the sign. 5 times 1 is 5. 2 times 2 is 4. We could put in 5 over 4. 4 goes into 5 once with a remainder of 1. Denominator stays the same, or we could use a mixed number of 1 1/4. Now, let's look at another way we could have done this. If we mix a fraction with a decimal. In the first one, I went ahead and I took the decimal and turned it into a fraction. So now let's take the fraction, turn it into a decimal. Let's rewrite this as 3.5 times, and I don't like the X. This is algebra class. Let's use the dot, right? Times negative 1/2. Let's rewrite that as a decimal. And while we're at it, positive times negative is negative. So let's get rid of the negative sign for now. Put that to the side. And 1/2 is going to be 0.5. I think I did this a little bit ago, right? So now let's go ahead and multiply these numbers using the traditional algorithm. And 5 times 5 is 25. Carry the 2. And 5 times 3 is 15. Plus 2, 1, 7. I have 1 decimal place here. 1 past the decimal there. 1 plus 1 is 2. Move it over 2 places, and I get 1.75. 1.75. Now, if you converted this over to fractions, you're going to end up with 1 3/4. Watch this. So let's do 3.5. This is kind of tricky this way, because you have to write it as 3 5/10, right? And multiply that times 1/2. Again, I know it's negative 1/2. I'm just putting that to the side for now. And then I could simplify 5/10 to 3 1/2 times 1/2. Now I could do 2 times 3 is 6 plus 1 is 7. Now 7 over 2 times 1/2. And then I end up with 7 times 1 is 7. And 2 times 2 is 4. 4 will go into 7 once with the remainder of 3. And the denominator stays the same at 4. So I would end up with a mixed number of 1 3/4. Either of these would be a correct answer for this activity. On the next one here, let's go ahead and look at that. How do I want to do this? Let's go ahead and do first negative times negative is positive, right? So we know our answer is positive. So let's do 1/4. And let's multiply it times 2 times 2 is 4. Plus 1 is 5. So 5 becomes my numerator. My denominator stays as 2. Now 5 times 1 is 5, and 4 times 2 is 8, and I end up with 5/8. Over here, my mind's thinking right now, Mr. T, is that correct? And if I think about it, the multiplication sign is like the word of, so 1/4 of 2 1/2. Yeah, that probably sounds about right. 1/4 of 2 would be 1/2, and 5/8 is a little bit more than 1/2, so that accounts for the 1/2 part. So a little bit of checking my work there just by using estimation. On the next one, negative times negative is positive, so my answer is going to be positive. And here I want to go ahead and probably go mixed number to improper fraction. So 10 times 5 is 50, plus 1 is 51 over 10. And I'm going to divide that by negative 2/3. Well, let's just say 2/3. We already dealt with the negative sign by realizing that negative times negative is positive. So let's keep the first, 51 over 10. Let's flip the second, 3 over 2. And let's change the sign. Wow, nothing's canceling out. Okay, I'm going to have to deal with this, I guess. 51 times 3 is 153. And 10 times 2 is 20. I could enter. I believe IXL will take 153 over 20. But 20 goes into 53, 5, 6, 7 times? That would get you to 140, leaving with the remainder of 13. So 7 and 13/20ths would work. Last two problems here. If I look at this one here, first of all, it's negative divided by a positive, so my answer is going to be negative. Let's remember that. So let's go ahead and let's turn 4/5 into a decimal, okay? Now, 1/5 would be 20%, 4/5 would be 80%, so it should be 0.8 divided by 5. 0.5 actually. If it was multiplication, this would be a lot friendlier. Tell you the truth, I kind of like the idea of turning the decimal into a fraction. Let's do 4 over 5. Let's divide it by 0.5 is 1/2. Now let's keep the first. Let's flip the second. Let's change the sign. 4 times 2 is 8. 5 times 1 is 5. I could put in 8/5. 5 goes into 8 once with a remainder of 3. And my denominator stays as 5. And then over here, let me see. How do I want to do this one? It is multiplication. So I think I'm going to go ahead and let's go ahead and write this out as 1/5. We're going to go with fraction times mixed number. So 9 and 0.5. 0.5 is actually 1/2, right? So 9.5. And this isn't positive times negative, so I know my answer is going to be negative. Oh, gee, I guess I should have put a negative sign. See, forgot it's going to be negative. So over here, let's go 1/5. Let's multiply that times 9 times 2 is 18, plus 1 is 19. And that's going to be over 2. This is multiplication, so now I go straight across. I have 19 over 5 times 2 is 10. 10 goes into 19 once with a remainder of 9. And denominator is 10. All right. Now, for those of you who have stuck around to the end of this nearly 25-minute video, I've got a bonus for you. Let's go back to where we had mixed number times mixed number. And I'm going to clean this up a little bit here. And I'm going to show you how you can use a calculator to do this. Now, remember that you have a division sign here, right? So let's do 2/3 as an improper fraction. 2/3, or 2 1/3 is an improper fraction. 3 times 2 is 6 plus 1 is 7. 7 over 3. We're going to divide this by 3 times 1 is 4, plus 1, or 3 times 1 is 3, plus 1 is 4. And this is negative over 3. Now, remember every fraction is a division problem. So technically, we could do 7 divided by 3, put that in parentheses, divided by, and then this in parentheses, -4 divided by 3. All I've done is I've taken the fractions and represented them as division problems. So let me grab a calculator here, and I'm going to show you how you can put this into your calculator and go ahead and work it out that way. Now, you might be like, well, calculator's cheating, but I mean, you at least have to know how to convert mixed numbers, right? Mixed numbers over to improper fractions. So you create your improper fractions here. Let's use a parenthesis here. Do 7 divided by 3, 7 divided by 3, parenthesis. And then we're going to divide that, and then put the -4. Negative sign is down here by the decimal, down here at the very, very bottom. The negative sign is different than a subtraction sign. If you have a negative number, be sure to use the negative sign. So -4 divided by 3, close parentheses. We hit enter, and we get -1.75. Now, what if you wanted that as an improper fraction? Well, you could go to your math menu, and you could hit fraction. It's already 1. You'd say take the answer, make it a fraction, and you could have it as an improper fraction, -7/4. Now, I'm not sure, but I believe you can actually make the calculator, some calculators, this particular calculator at least I know, turn it into a mixed number for you. All right, I edited that out because apparently I couldn't get the calculator to turn it over to an improper fraction, or an improper fraction to a mixed number. So, but that is how you could use a calculator to handle these particular problems, if you'd like. So that concludes all of my examples for IXL A1.B.5 Multiply and Divide Rational Numbers. Good luck with your activity.